Hello guys, how are you doing? Picture this. You are watching a Formula 1 car race and two cars in particular are leading above every other car in the race. Now, you come to know that the first car is traveling at a speed of 170 km per hour while the second car is traveling at a speed of 200 km per hour. Now tell me, if both the cars are at the same distance from the finish line, which car would finish the race first? Well, obviously the second car would reach the finish line first. And that's correct. But why is it so obvious? I mean, how can we be so sure? Well, that's because the speed of car 2 or the second car is higher than the speed of the first car. So from this we can say that speed essentially is a physical quantity that tells us how fast or slow an object moves. However, in more physicsy terms, I can define speed for any moving object as the rate of change of its distance with respect to time. Now mathematically we can write this as speed is equal to distance upon time. Now speed is a scalar quantity guys, which means we need only its magnitude to completely define it. Now just like speed, we have another physical quantity called velocity. Now velocity is essentially the rate of change of displacement with respect to time, which can mathematically be written as velocity equal to displacement upon time. And it turns out that velocity is a vector quantity. So in a way you can see that speed and velocity are cousins, just like distance and displacement. One is a scalar quantity while the other is a vector quantity. We'll learn more about velocity in a later video. Now as I told you in your previous standard, that based on this formula, speed is equal to distance upon time, we can have numerous units for speed. For example, we can have units like kilometers per hour, meters per hour, kilometers per second, and so on. And you should know that all these units are valid. Therefore, we can call them non-standard, commonly used units as they are applicable in certain contexts. For example, we express the speed of light in kilometers per second because light actually travels that fast. Similarly, we can express the speed of a snail in meters per hour because snail actually travels that slow. But on top of all this, you should know that the SI unit of speed is actually meters per second. Great! Let's look at a situation now. So imagine a friend of yours who lives 10 kilometers away from your house invites you for a birthday party. You decide to take your car and drive the first 5 kilometers at a speed of 30 kilometers per hour, the next 2 kilometers at a speed of 15 kilometers per hour, and the last 3 kilometers at a speed of 50 kilometers per hour. Now, given this information, tell me, what is your speed throughout your entire journey? Now, if you really think about it, it's an ambiguous question, right? Because you traveled at different speeds at different instances of time. For example, you traveled at 30 kilometers per hour, 15 kilometers per hour, and 50 kilometers per hour at different instances of time. So you did not travel at a constant uniform speed. So a more sensible question should be, what was your average speed throughout the journey? And from your previous standards, you already know that average speed is actually total distance covered divided by total time taken. In our case, this comes out to be 10 kilometers divided by 0.36 hours or 27.78 kilometers per hour. Now, average speed, as you can see, gives us an overall estimate of the rate at which the distance was covered with respect to time. But on the other hand, the speeds 30, 15 and 50 kilometers per hour were instantaneous speeds. They were the speeds that the speedometer of the car showed at any instant of time. So you can see that here the instantaneous speed values are clearly different from the overall average. So from this we can understand that instantaneous speed need not be equal to average speed at all, because instantaneous speed is the speed at any instant of time, while average speed is the overall estimate of the rate of change of distance with respect to time. So I hope you are clear about the difference between instantaneous and average speeds. So let's talk about the next concept of uniform and non-uniform motion. So what is uniform motion? Well, you see, when an object travels at a constant speed, it is said to be in uniform motion. Or putting it more formally, when an object covers equal distances in equal intervals of time, it is said to be undergoing uniform motion. Now, when an object undergoes uniform motion, you would observe that its instantaneous speed throughout the course of its motion would be equal to its average speed. Now, until this condition is satisfied, the object can't really undergo uniform motion. Now, once you understand the concept of uniform motion, the concept of non-uniform motion is pretty self-explanatory. So, when an object moves in a way that its speed changes repeatedly throughout the course of its motion, we say that the object is undergoing non-uniform motion. And of course, when an object undergoes non-uniform motion, its instantaneous speed is not equal to its average speed, which means there will be at least one instant where the instantaneous speed will be different from the average speed. Now we can put this same idea in a different way as well. We can say that when an object undergoes non-uniform motion, it covers unequal distances in equal intervals of time. Now, a great example that depicts uniform and non-uniform motion is the story of the tortoise and the hare. Yes, the one you learnt in your kindergarten. And that's why I'm sure all of you know what happens in that story. So tell me guys, among the tortoise and the hare, who do you think moves uniformly and who moves non-uniformly? You see, the tortoise, even though super slow, moves uniformly throughout the race, which means he covers equal distances in equal units of time or in equal amounts of time. But the hare moves very fast initially, but once he realizes that he has a large lead over the tortoise, he goes for a nap. Now you can see that although hare's speed was large in the beginning, it became zero after a short period of time. So hare did not cover equal distances in equal units or equal amounts of time. So we can say that the motion of tortoise here is uniform, while the motion of hare is non-uniform. Okay guys, now before I end this video, I'm gonna ask you a couple of questions related to the units of speed. So here is the first one. A cheetah travels at a speed of 100 km per hour at a particular instant. What would be the speed of cheetah in meters per second? Now this one is a pretty easy problem to solve. First of all, we write the speed of cheetah as 100 km per hour and we rewrite this as 100 km divided by 1 hour. Now I can rewrite the numerator once again as 100 multiplied by 1 km divided by 1 hour. Now because I want to convert it into meters per second, let's replace the value of 1 km in terms of meters and 1 hour in terms of seconds. Now once we do that, the expression changes to 100 multiplied by 1000 meters divided by 3600 seconds. Why? Well, because 1 kilometer is equal to 1000 meters and 1 hour is equal to 3600 seconds. Now simplifying this, we get the value of speed of cheetah as 27.78 meters per second. Great! Let's solve another problem now. So who do you think moves faster? A deer running at 24 meters per second or a falcon flying at 90 kilometers per hour? Take some time and try getting the right answer, guys. So guys, to be able to compare the two speeds given in the problem, I need to have them in the same units. So I can either change the speed of the deer from meters per second to kilometers per hour and compare it with the falcon, or I can change the speed of falcon from kilometers per hour to meters per second and then compare it with the deer. For this problem, I'll change the speed of deer from meters per second to kilometers per hour. But as far as you are concerned, you can do it the other way as well. So to convert the deer's speed in kilometers per hour, let's first of all write its speed in meters per second as 24 meters divided by 1 second. Now I can rewrite this as 24 multiplied by 1 meter divided by 1 second. Now we know that 1000 meters is equal to 1 kilometer. So 1 meter is clearly equal to 1 upon 1000 kilometers. So let me replace this value in the numerator. Similarly, I know that 1 hour is equal to 3600 seconds. So 1 second is equal to 1 upon 3600 hours. Let's replace that in the denominator. Now once I do that, my expression becomes 24 upon 1000 divided by 1 upon 3600. On rearrangement, I get 24 times 3600 divided by 1000. Now this value clearly comes out to be 86.4 kilometers per hour. Now the speed of falcon given in the problem is equal to 90 kilometers per hour. So who do you think is moving faster? Well, clearly it's the falcon that is moving faster in this case over here. So guys, with that, we have reached the end of this video. I hope you had a good time learning about the concept of speed with me. In the next video, we'll solve some problems based on the same concept. For now, let's summarize whatever we have learned so far. Speed is defined as rate of change of distance with respect to time. Mathematically, this can be expressed as speed is equal to distance divided by time. Speed is a scalar quantity. Velocity is the rate of change of displacement with respect to time. Mathematically, this can be expressed as velocity is equal to displacement divided by time. Velocity is a vector quantity. There are several commonly used units of speed like kilometers per hour, kilometers per second, meters per hour, etc. But the SI unit of speed is meters per second. Instantaneous speed is the speed of a moving object at any instant of time. Average speed tells us the average rate at which an object covers a certain distance in a certain amount of time. Average speed may or may not be equal to instantaneous speed. An object is said to be undergoing uniform motion when it covers equal distances in equal intervals of time. In this case, the instantaneous speed of the object is equal to the average speed of the object throughout the course of its motion. An object is said to be undergoing non-uniform motion when it covers unequal distances in equal intervals of time. In this case, the instantaneous speed of the object is not equal to its average speed throughout the course of its journey. There is at least one instant when the instantaneous speed is different from the average speed.